Greetings to everyone. Hope you all are hale and hearty. I'm Ujaswita Priyadarshini Gaur, an undergraduate from MBM Engineering College, Jodhpur. And in this module, we're going to be discussing the solutions to sample paper number 3, part 2. That is the questions from question number 6 to question number 10, targeting class 9th. So without any further ado, let's get started. So the first question of the module says, state 3 key postulates of Dalton's atomic theory. And in the or part, we have named 3 different models of atom and the one who's formulated them. So approach, as we discussed in the previous modules as well, we're going to be dividing this question to 2 parts. In the part A, we'll be discussing the key postulates of Dalton's atomic theory. And in the part B, we'll be naming the 3 different models of atoms and the ones who formulated them. So the part A says, Dalton's atomic theory. Now, the main points of Dalton's atomic theory include that everything is composed of atoms, which are indivisible building blocks of matter and they cannot be destroyed. All atoms of an element are identical. The atoms of different elements vary in size and mass. The compounds are produced through different whole number combinations of atoms. And then finally, a chemical reaction results in the rearrangement of atoms in the reactant and the product compound. So these were basically the main points of Dalton's atomic theory, or we can say these were the observations. Now, the atomic theory has been revised over the years to incorporate the existence of atomic isotopes and interconversion of mass and energy. In addition, the discovery of subatomic particles has also shown that atoms can be divided into smaller parts. However, Dalton's importance in the development of modern atomic theory has been recognized as the designation of the atomic mass unit as Dalton. So this was basically the first atomic theories ever proposed. And yes, it had a lot of flaws. Like the main misconception that this theory had spread was that atom could not be divided into smaller parts, or that atom is the most indivisible entity. But the later discoveries had, and we also know that atom definitely has a lot of subatomic particles like proton, neutrons, and electrons. These are the common ones. And then there are quarks. They have bosons, Higgs bosons, and they have other force carriers as well. So yes, this was one of the basic models. However, it had certain misconceptions, but yes, this was the fundamentals of the first of the study of their atomic structure and atomic theory. And the three postulates and the answer to this question states that every matter is made up of atoms that take part in a chemical reaction. Atoms can neither be created nor be destroyed. And finally, each element is made up of atoms with different masses and chemical properties. So, in short, if you want to represent atomic theory as symbolic representation, you can understand this better by this: that if there is this is your oxygen atom has 16 of mass units each. That is, this is your 16 mass units. It's the weight of oxygen, and then you have two hydrogens at one mass units each. That makes two mass units for the two hydrogen atoms, one here and one here. So this is nothing but it's simply H2O. That is your water. One molecule of oxygen, two molecules of hydrogen. And then you put it together to make a water molecule, which is 18 mass units. And it's combined of 16 plus 2 mass units. So this was a brief of what Dalton's atomic theory tries to state. And the next part says the three models that we're going to discuss is the first is your Thomson's model of atom. It was formulated by J.J. Thomson, and this was also called the watermelon model. Then you have the Rutherford's model of atom, and this was formulated by Ernst Rutherford as the name of the model itself. And then you have the Bohr's model, which is formulated by Niels Bohr, as again the name of the model is already specified. Now, the first was John Dalton in 1803. The second was J.J. Thomson, that was a pie pudding model in 1904. And then you have Ernst Rutherford's model in 1911. And then you have Niels Bohr model in 1913. And you have Erwin Schrödinger's model in 1926. This is the most comprehensive model of atom. It's most widely used and accepted because all these four had a lot of flaws, and there were a lot of things that these four did not incorporate. So there are plus points in this model. It is widely accepted and it's far better as compared to these four, and we're going to discuss each in the next module. So yes, right now the answer to our question is the three models are Thomson model, Rutherford model, and Bohr model that were devised by J.J. Thomson, Ernst Rutherford, and Niels Bohr, respectively. Now the next question says, is blood a connective tissue? And give the important functions of blood. So yes, blood is a type of a fluid connective tissue as it connects every part of the body, and it also develops from the mesoderm of an embryo. Now this is very important. The building block of blood is the mesoderm of an embryo. The two important functions of blood shall include: first, it helps in the transportation of important nutrients and your hormones and gases and eliminates waste materials. And in the second part, we have the blood contains white blood cells that helps in fighting viruses and diseases. So you have basically, if I can just concise the whole thing about blood, you have RBCs, you have what is called the WBCs, and then finally you have BPs, there are blood platelets, right? So RBCs are the ones which give you that red kind of a color. Like if you can see this right here, this is your white blood cells, red in color. This is also red in color, and this one makes the blood look red. Then you have white blood cells. Now, white blood cells are what actually here, these are going to give you that immunity. They build your immunity to fight viruses and diseases and then produce antibodies which can fight those viruses and diseases that get into the body. And then you have some blood platelets which are right here. These are your platelets. Again, these platelet counts are also a part of your wellness and healthy being. And then finally, the fluid in which your red blood cells and your white blood cells and your platelets are going to flow is your plasma. This is a fluid. This is this orange fluid right here. If you can see the orange fluid, the medium in which your red blood cells, white blood cells, plasma, and platelets are going to float together to make uh, the whole constituents of the blood is nothing but plasma. So this was the structure of blood and the components of blood. And yes, definitely blood is a fluid connective tissue because it is connecting different organs and different parts of the body together. So the next question says, what happens to the kinetic energy of a falling object on hitting the ground? So first, let us imagine this girl right here. We are here where this girl is standing and she's throwing this ball from a height down here, right? This is so basically, as we have already discussed in the previous modules as well, when you have raised this ball to uh, this height from the ground, this height from the ground, when you raised it, it had potential energy. At this point, it has potential energy which is due to position of a body. This is the potential energy point. And when this ball is going to fall down and is going to reach this point, or say this point right here, this whole potential energy shall convert to kinetic energy. That is the energy which comes due to motion. And you can see here it is stationary, it is in a position at that potential energy. And when it is coming down, now you're changing its motion, you're changing its position, you're giving it a motion. So where motion comes into play, your kinetic energy automatically comes into play. So when it's going to reach here, it is going to have a complete amount of kinetic energy. This was the basic energy conservation. Now let us look at the proper answer to this. So when a falling object is going to reach the ground, there is going to be a dissipation of energy. That is a reduction of energy, or there will be a utilization in such a way that the generation of heat will be there when the object is going to collide with the ground. There will be a production of sound as well due to impact, and then your kinetic energy is ultimately lost in the process. That means you fully convert into kinetic energy, and finally, your kinetic energy when you reach the ground becomes zero. So that's how your kinetic energy is ultimately lost in the process. Yes, when it hits the ground, it generates an amount of heat because it is colliding, and then you have a production of sound, definitely, because when it's going to hit the ground, it is going to have an impact sound. And then finally, your kinetic energy is ultimately lost because when it comes to rest here, yes, your kinetic energy is going to get lost. Now let's move on to the next question. Now this says, Question number 9. Describe 3 characteristics of sound. So, the 3 characteristics of sound basically are frequency, which is the rate at which the sound vibrates or the speed of the vibration. Then you have amplitude, which is basically refers to how big or small the vibration is. And finally, the speed of the sound is defined as the distance traveled divided by the wave per unit time. So that is nothing but d divided by t. That is a formula for speed that we have already discussed. Now the parameters just have changed for this to be the speed of sound, this to be the distance traveled by the wave, and this is the time it takes to cover this much amount of distance. And now let us try to understand this characteristics of sound waves. This is a diagrammatic representation. This is your sound wave. This dark, this basically is your sound wave. And then you have, as I told you, amplitude is the how big or small the vibration is. So this is your vibration. This right here, this height right here, from this peak of this curve, to this base, is going to be what is your amplitude, and the wavelength is going to be the distance, because between this high point and this high point is what you get the wavelength, right? And from this point to this point, as you can see if this is the one cycle, and after this point it is going to repeat its in nature. So this is your one cycle, this is your other cycle, and this is repetitive, right? In one cycle, now where is the one cycle completed? Right from here to here, and then another cycle starts from here to here. So this is going to be the time for your one cycle. This right from here to here is going to be a time for one cycle. These are different parameters of sound. These are the different characteristics of sound. And now the next question is, name and describe the process to separate a mixture of 2 miscible liquids. Now the mixture of 2 miscible liquids are normally separated by the process of distillation. That is, the process is used when 2 liquids in a mixture have different boiling points. So we add a mixture in the distillation flask, which is attached to a condenser outlets. Then the mixture is heated slowly, and the liquid with the lower boiling point vaporizes, and then it condenses in the condenser, and the separated liquid is then collected in another flask. So this process is basically the process of distillation in a flask. And this is how we're separating 2 miscible, that is 2 completely soluble liquids, which are soluble into each other completely, like ink and water. If you have mixed ink and water together, they're completely miscible liquids, and distillation is one such process which can distinguish, or which can put ink and water separately after they have been mixed, or the process of separation of these 2 miscible liquids is distillation. And you can just understand this by, let us say this liquid B right here is ink. That is your, this is your ink, INK, and this is going to be a water, H2O. So when you mix ink and water, since they are miscible, they are going to form another compound which is going to look the same. That is, they do not have different layers. As you can see here, this meniscus is not there, because they are 2 miscible, they are completely soluble in each other. So you have a completely one liquid, and these atoms have just been shown to make you understand that this, where has this liquid A gone. So this liquid A has completely dissolved in the liquid B, and you have another liquid right here, which is the combination of both of them. And when you make this liquid, this test tube undergo a distillation process, you will definitely have this liquid A and liquid B again coming differently, they will be separated. So with this, we come to the end of the module. Thank you so much to be a very patient audience, and I hope I was able to deliver the subject and the fundamentals clearly to you guys. So yes, we'll meet in the next module. Until then, keep learning and keep growing. Thank you so much.